Welcome back to the second devlog for Slaughter Mask, a Souls-like set in the world of 1980s horror. If you missed the first video, the link is in the description. Today, we're diving into our new interaction system, the start of the inventory system, our transition to the gameplay ability system, and a major start to enemy AI behavior. So let's get into it. To start things off, let's take a deep dive into the new interaction system. To build this, I decided to use a modular actor component. The reason I went this route is for flexibility. It keeps the logic separate from the player character, meaning I can easily reuse this same component on other characters. The heart of the system is a function called the interaction sphere trace. Instead of using a thin line, which can feel too precise and frustrating for a player, a sphere trace checks a larger volume in front of the camera. It constantly looks for any object that is marked as interactable. When it finds one, that item is added to an array called interactables in range. From there, the system does a quick check to see which specific item was last overlapped or highlighted, designating it as our active interactable. Now, for the actual input logic, I wanted to support different types of player actions. When you press the Interact button, the system checks the interaction type of the object. For simple things, it's a quick press that triggers the action instantly. But for more heavy-duty tasks, like opening a stuck door or searching a body, the system requires a hold. It tracks exactly how many seconds you've held the button down, and only once that threshold is met does it move to the next phase. Finally, we have the Interact with Active Interactable function. This acts as a final failsafe. It checks your distance from the object to make sure you haven't moved away, then triggers an animation montage to make the action look natural. I'm using montage notifies here, essentially digital bookmarks in the animation, to tell the game exactly when to fire off a blueprint interface message. This ensures that the code and the visuals stay perfectly synced, only updating your inventory or changing the world state at the exact moment the character's hand makes contact with the object. Next, let's shift gears and talk about how you'll actually be managing your gear. The inventory system is still very much a work in progress, but the foundational architecture is officially in place, and it's already handling the heavy lifting behind the scenes. Everything kicks off the moment the interaction system triggers the Add to Inventory function. The system takes the item you've just discovered and places it into a Found Items array. To figure out exactly what that object is and how it behaves, the code performs a lookup in a master data table. This is the brain of the system. It breaks down the item's raw data to determine its type, whether it's a heavy blunt weapon, a vital healing consumable, or a key item needed to progress. One of the most important aspects of a survival-focused game is resource management, so I've built in logic to handle item stacking. When you pick something up, the system immediately checks if that item is stackable, and then looks at your current inventory to see if you've already hit the maximum limit for that specific stack. If your inventory is already full for this specific type of item, the system will return a failsafe, preventing you from picking up more than you can carry. If you do have the space, the item is assigned to a fresh inventory slot, and its individual weight is added to your total carry weight. In a Souls-like environment, every ounce counts, so keeping an eye on that total weight will be crucial for your movement and survival. To make all this data readable for the player, I've developed a dedicated inventory widget. I wanted the interface to feel organized and professional, so I implemented a tab-based navigation system. Instead of scrolling through one giant, messy list, you can flip through different categories to find exactly what you're looking for. When you highlight an object, a Details panel on the right side of the screen populates with everything you need to know. It displays an icon of the item, its name, a description of the item, and its specific weight. It's all about giving the player clear, concise information so they can get back to the action as quickly as possible. Now, I want to talk about what is probably the biggest technical turning point in the project so far. I decided to strip out my original custom-built ability system and replace it entirely with Epic's Gameplay Ability System, or GAS. If you aren't familiar, GAS is an incredibly powerful, highly optimized framework used in games like Fortnite to handle complex combat and character states. To get this running, I headed over to Rider to dive into the C++ side of things. I started by creating a custom ability system component and attaching it to our core character-based class. By doing this at the base level, I've ensured that every single character in the game, whether it's the player you control or the enemies hunting you, inherits this system and is capable of using the exact same logic. Next, I built the attribute set. Think of this as the stats engine for the game. Right now, it's managing our health and stamina. But it's not just a set of numbers. I've written specific functions that broadcast events whenever these attributes change. This is vital because it creates a bridge between the heavy back-end code and the visual experience. It allows us to use blueprint logic to trigger things like screen shakes, blood splatters, or UI bar updates the very millisecond a value shifts. I also developed a custom gameplay ability class. While Epic provides a great foundation, I wanted the flexibility to add my own unique functionality that doesn't come out of the box. This allows for much deeper control over how the slasher-inspired mechanics feel in practice. Once the C++ foundation was solid, I jumped back into the Unreal editor to actually build the abilities. The beauty of this system is its modularity. For example, when we look at the light attack ability, it's not just a single script. It calls a function from our combat system component, plays the animation, and then sits in a waiting state. It listens for a specific event to tell it the attack has finished before it safely ends the ability. The real superpower of using GAS, though, is gameplay tags. These are essentially labels we can slap onto a character to define what they are doing at any given moment. It allows us to easily block or allow certain actions based on the character's state. For instance, if a character has the equipping tag active, the system automatically knows to block any attack commands. It prevents the animations from overlapping or glitching out, ensuring the combat feels deliberate, polished, and, most importantly, fairly punishing. Finally, let's talk about the brain of the beast, the AI behavior system. In a horror game, the AI is what creates that feeling of being hunted. So I've put a lot of work into making our enemies feel intelligent and reactive. To do this, I developed a master behavior tree that serves as a universal logic template. By using this base tree, I can easily create specific copies for different enemy types, ensuring that while every monster has a unique flavor, they all share a core, sophisticated intelligence. This behavior tree is built around three primary states: passive, investigating, and combat. Each one completely changes how the enemy perceives and interacts with the environment. In the passive state, the enemy isn't just standing around waiting for you to show up. I've implemented two main modes here: random roaming and path patrolling. In roam mode, the AI explores a defined radius around its spawn point, which gives its movement a natural, unpredictable feel. In patrol mode, the AI follows a specific, predefined path, perfect for that classic horror trope of a killer stalking a hallway. They will stay in this loop indefinitely, or at least until they catch a glimpse of the player. The investigation state adds that essential layer of stealth and tension. The AI is constantly listening for environmental sound cues, like the sound of your footsteps on a wooden floor. If you make too much noise, the enemy will break its patrol to physically investigate the location of the sound. This forces the player to really consider their movement. If the AI doesn't find anything, it doesn't just reset instantly. It stays on high alert for a moment before eventually returning to its original patrol route. Once the player is spotted, the AI transitions into the combat state, and this is where the Souls-like influence really comes to the forefront. I wanted to make sure the player couldn't simply kite the enemies at a distance, so I've implemented a jump attack as a gap closer. If the AI detects that the player is too far away for a standard strike, it will launch itself forward to close the distance instantly. If the player is within range, The AI will then select an attack using the gameplay ability system we discussed earlier. But a good fight isn't just about the enemy attacking, it's about them reacting to you. When the player swings their weapon, the AI doesn't just take the hit. It has a chance to either block or dodge your incoming attack. This isn't just a fixed loop. The frequency of these defensive moves is governed by a random probability variable that I can tune for each specific enemy. This means I can create a heavy, tank-like enemy that blocks almost everything, or a nimble, frenetic slasher that is constantly dodging out of your reach. It makes every encounter feel like a dangerous, unpredictable dance where the player has to actually study the enemy's behavior to survive. Thanks for sticking around. If you enjoyed this update, hit that subscribe button to keep up with the build as it happens. See you in the next one.